No SS, 3S. Okay, SSS. So triple S for both. Then double A will do because the third one will naturally be the same. And then SAS. Okay, the order is important, especially for congruency test, is because if I tell you that triangle ABC is congruent to triangle DEF, I'm telling you angle A is equal to angle D. Okay, I'm telling you angle B is equal to angle E. I'm also telling you angle C is equal to angle F. So if you anyhow sequence them, then the angles will mix up. So the order of you writing is super important. Okay, not just that, you're telling me that the side AB is equal to the side DE. The side BC is equal to the side EF. So the order is very important. Last one, AC will be equal to DF. So they have equal sides, equal angles. So for congruency, they have equal corresponding angles. And then they have equal corresponding sides. Corresponding means the matching ones. Okay, so this is for congruency. Next one is similarity. If I tell you ABC is similar to DEF, then I'm telling you that same thing, this angle is equal to this angle. This is equal to this. Okay, and then the last one, angle C is equals to angle F. So I'm telling you they have equal corresponding angles, but the next thing we compare is the ratio of the corresponding sides. Ratio, the proportion. So AB ratio with DE is equal to BC ratio with EF. And then the last pair is AC ratio with DF. Okay, of course you can reverse. You can say FD and with CA. You can reverse the order, it's fine. So the only difference is same thing, corresponding angles equal. But ratio of corresponding sides is the ratio. So the difference is this one we talk about ratio, not the exact length. Okay, but for congruency, we are talking about the exact length. So this is the overview for 6.1 and 6.2. Can? See, this one whose one? This one is Alexia's one. Why what?
Why do you need congruency?
Because you want to, if you want to make the exact same thing, then you need to make sure that you know the dimension. If two sides are equal, the angle is the same, then the thing you cut out will definitely be the same thing. Yeah. Okay? Yes. So next time, people say, in our office, there's always a joke, right? Then got one teacher tell the other that, oh, you are quite chubby. Then the teacher say you are congruent to me. Yeah, but we all know it's not possible, right? But he's just returning the same thing to the other teacher. Okay, it's a secret. Okay, through 6. Okay, but anyway, as a recap, look at 6. Okay, it says that ACD, this one, okay, is similar to ECB. So when it's orientated in this way, it's difficult to compare. So what you can do is every time when they tell you ACD, right? Then you look at the shape ACD in this order, right? Then you go and draw another one that looks like the ACD. Can draw smaller, bigger, doesn't matter. Just draw beside it. So ACD is similar to ECB. So you follow the same order. So E, C, and B. So you draw a smaller one next to it, And then this is supposed to simulate the black triangle that I shade. Then you go and transfer every information you know about ECB onto the smaller one that you draw. So EC, if you compare it, is y plus 4. So go and write it down there. Okay, then BC is 2. Okay, so now they already tell you they are similar. Then they say, can you find an equation relating x and y? So definitely we need to use ratio of the sides to establish the relationship. So first thing I can do is, of course, I will compare this side, which is x plus 2, with this side. So the ratio of this side should be equal to the ratio of the base. So the base here is y plus 4. I will compare it with 2. No, it's just 4. Sorry, my bad. Just 4 only, right? The base is just 4. So 4, I compare it with 2. So I'm just establishing the ratio between the two corresponding sides. The top part and then the base. Then I just create the equation. So this one I multiply 2x plus 4. This one I multiply by 4. Or actually, okay, never mind. Okay, so if you simplify everything, you end up having 12. Okay, so x is just 2y plus 6. Can you see that? So this is what you want to show as the answer. They just want you to establish the ratio and then prove that it gets an equation. That's all. Okay, second part, they say, hence, can you give me a possible even integral value of x and y? Possible means you can choose. Yes. Integral is like integer. Okay, so they want you to state one possibility. So let's try to come up with a value of y that is an even integer. So the smallest even integer we can think of is 0, right? But we want to move on to the next one because we don't want this length to disappear. So let's say y is 2. Then what would x be? 10. So this is one possible answer. You can change y equals to 4, the next even number. Then you will have 14. Okay, this is the other possibility. So many possible answers, just give me one. Okay, just give me one pair will do. So whatever they have written here is just one possibility. You can have other answers.
Wait, why cannot be 4? Because there will be longer than BC, which is
Oh, if we look at the if we try to make sense of the diagram, it does seem that this one, if it's 4 or anything longer, then the diagram will make sense. Also possible. So you just take it to be this law. Okay, but if we never say that the diagram is drawn to scale, technically we should accept all other possibility lah. Yes.
Can we take x as 2?
X as 2. Then your y will end up negative. So cannot. Okay. So that is 6. So this kind of question, they like to ask where you have another shape that is orientated in a different way. That means opposite direction as what your existing shape has. Then you need to compare. So when you meet up with this kind of question, redraw the second one. Then you draw it side by side, it's easier to compare. Okay, next type is the last one, 10. Okay, I told you all before, right? Similar triangles only look in two ways. Either the stacked triangles, like that, or the pyramid, okay? Or it's like a ribbon form. But no matter what kind of shape you see, there must be a pair of parallel lines for similar triangles. Okay? So this is the types of similar triangles that they like to test you. You will see these two kind of shapes. So always look out for these two kind of shape. So first thing, they say, can you find a similar triangle that is similar to QTR? Look for the ribbon extend. So can you see TC? TC? No, not TC. This one. Can you see the ribbon? If you extend the line sufficiently long enough, you will see that These two are also the parallel line. Although the arrow they draw at the lower part, but the whole line should be parallel. Okay, so when you have this case, then you know they are similar for sure. Next is to determine the correct match. So Q, we know that this one alternate angle with this one. So that means when they say QTR, you need to match it with what? ATS.
Can you just like redraw the thing?
Can. If you prefer to redraw, then can redraw. A what? AQP also can. Because it's also alternate angle. Yeah, can. Is it every lesson you go toilet? Like, seems like it. I suddenly feel like deja vu. Okay, so this one, small one, or like what Shu Huai say, the bigger one, they are all similar. Okay, so if I want to find the length of AT, they are not equal, they are similar. Alternate. Can you see parallel line, the zigzag line? Alternate angle. Yeah, so that's why that one is equal. Next one that is equal is the vertically opposite. So you can use AA test to show me they are similar. But question never asked, so we don't need to show that. Okay, I want to compare the ratio of the corresponding side. So if you don't want to redraw and you already know that these two are similar, you can use the order to help you. So you want to find AT, you must compare its ratio with QT. So you can write that pair down first. Then the next pair you compare with is TS. You will compare it with TR. Then the last pair you can establish is Q. Did I write the order wrongly? AT, then TS. I must start from there, right? So the last one is AS. I must compare with QR. So why I write all three is because I don't know which pair I want to pick. But I will put in the info first, then I can decide which pair to pick. So AT, I don't know. For sure, I need to find this. QT, I know. QT is 10. TS, I know is 5. TR, I know is 8. Okay, so clearly I don't even need to care about the third pair already because I already have enough info to find AT. So just cross multiply 5, 8 times the 10. So I will get my answer 6.25. Okay, so this one is part B. Okay, next, they say, can you identify a triangle that is similar to this CBT? Remember, you only have two types. If you cannot find a ribbon with a parallel line, you must find the stacked triangle. Can you see this one? And there's a pair of parallel line. So now we are looking at case 1. Okay? So that means CBT must be similar to CPQ, the bigger one.
This one?
Yes.
Why can't it be
AST. Because I don't have a parallel line to prove that I have one more angle that is the same. Yeah. So CPQ. Okay, how come I can know that these two are similar? Because if you have a parallel line, these two corresponding angles are equal. These two corresponding angles are equal. So by AA test, they must be similar. If they ask you to prove. But if they never, just leave it like that. Okay, last one. They want you to find what is AC. This one. But in order to find AC, I need to have what? CT. Because I already have AT. Just now I found already 6.25. So now question wants me to find AC. But I can find AC only if I know CT. So now I look at the stacked triangle. This is my CPQ. The smaller one is my CBT. So I just put in every info I have. This is 3. This PQ I know or not? Can I find PQ?
Yes.
How?
8 plus 3.
8 plus 2 plus 3. Because it's parallelogram, the opposite sides are equal. So actually this is 13 cm. Then my mission is to find CT. So that means I definitely has CQ. Do I have CQ? I don't have. Oh, I don't have CQ leh. Add these 3 up. Opposite sides of parallelogram. So this is 2 plus 3 plus 8. Okay, wait. What do I have? Oh, okay. So I can let this be. Okay, let this be x. So this is x plus 10. Okay, if you set up the ratio. So now I will set up the ratio. X over 10. X plus 10 over x. The ratio should be same as 13 over 3. Then you cross multiply and solve. Okay? So I'm just trying to use this example to show you. Sometimes the orientation is different, you can redraw. Okay? Sometimes you just need to recognize that similar triangle is either this or this. So you try to find the correct match. Okay? So that is the crux of congruency and similarity. Okay, the last concept is ratio of area and volume. Oh, okay, it's your snack break. I will resume at 1:07, okay? Okay, just now we have been talking about 2D. 2D, two-dimensional figures. Okay, all your triangles, whatever shape that we are talking about is two-dimensional. Okay, so when we talk about length, okay, we can use ratio of corresponding sides. Okay, but if I want the ratio of their area, they say that I just have to take the ratio of one of the side and then square it. That will give me the ratio of their area. So for instance, if let's say I say these two shape, right? The most simple one, like this is a square. So if I know that this is 2, 4, this will be 2, 4. So the ratio between them is always 1:2, correct or not? The ratio of their length is 1:2. Can you agree with that? Because this is L1, this is L2. If I find the ratio of their side, it is just 2:4, which is 1:2 if I simplify. But what about the area? The area will be 2 times 2 and then 4 times 4. Okay, so if I find the ratio of their side and then I simplify, it will be 4:16, which is 1:4. So they are saying that actually if I want to find ratio of the area of similar figure, all I have to do is to just square the ratio of the sides.
But then other sides are this.
So just like this one is 2:4 for one of the length, right? Then I multiply with the ratio of the other pair. So can you see that actually it is this thing square? So to find ratio of area of two similar shapes, we just square the ratio of one side. Yes. Only it is for any similar figure. So if it's pentagon and pentagon, I still square the ratio of one side. You look at the area. So if I use length, okay, so to find the area of this length is L1 times L1, right? To find this one is L2 times L2.
But what about for triangles?
Triangle will work the same way. Okay, wait, I show you triangle. This one. If I compare these two similar triangle, then I do a half times base times height for the small one. And then half times base times height for the second one. After I cancel and simplify them, I realize that actually I will get 2 over 5 square, which is the ratio of one pair of the sides. Okay, this one is also reduced to 2:5, right? So it is the square of one of the sides. So they try with many similar shape. They realize that if I want the ratio of the two similar figures, I just square one of the sides. Will do. Okay, so this is the formula they establish. So first thing first, they say that this triangle is similar to this one. Okay, but they purposely change the orientation. So let me change the orientation back. I can do that, but you can't. But you just tilt your head lah, huh?
I mean, we can if you let us do it.
Okay, so PQR cannot. Unless can I flip?
Teacher, this is literally paid to me.
Can I flip?
I flip the smaller line.
Wait, let me see. Can I flip? Aiya, this is not high tech enough. Okay, never mind. So, never mind. When this happens, you just redraw the smaller one. Redraw the ABC smaller one. So, PQR is similar to ABC. So, just redraw the smaller one and then put the length beside. So that it's easier to compare. They say PQR, like that, PQR. So, I also ABC. Follow the order. Okay, so now if I want to compare the ratio of the length, this one no problem. X divided by 9 should be the same as 4 divided by 6. This one is a recap from just now. So part A. So I cross multiply my 9. So 9 times 4 over 6. 3 times the 2, 6. Okay, so that's X. Okay, but they tell me that the area of this thing is 10. I want to find the area of this. And then they don't give me base. They don't give me perpendicular height. So I technically cannot do much except comparing the ratio. So I was told that area of ABC to area of PQR, I just have to square the ratio of one of their sides. So the ratio of one of their side is 4:6. So if I 230 is 49. Okay, this is what I know. So that means triangle ABC I know is 10. All I need to find is area of triangle PQR. So what I need to do is to cross multiply. So bring the whole thing down to divide lah. Correct. Any pair because the ratio should be the same. Okay, so what do you get? (22.5 cm squared). What was that for? So this one, just remember when you want ratio of their area, you square the ratio of one of the sides because it becomes two-dimensional. Before that, we are comparing length, right? But when you compare area, it's length times length. So you square the dimension. Yes. If not, you can just 90, then 4 times this. Then you go and divide by 4. Also same answer. Just taking some shortcuts. Okay, the working can be like that also. I just brought the whole chunk down. This one. Also can. Yeah. Okay, so that is how you make use of area ratio. You just need to remember if you want the ratio of area, you square one of the sides. Okay, quite easy to understand. Ravan. I keep wanting to call you Raven because last time I got one student called Raven Rao. You know the top student, in the hall, that one? He has a signature luggage that he brings to school every day for lesson.
He's a top student.
Yeah, he's the top student. He go RI.
So I guess the luggage.
So he will like come to class with a luggage. A very yeah, suitcase.
Okay, we should
Like luggage.
Actual suitcase.
Oh,
No.
those.
Yeah, those that you
ones.
can pull up. Yeah, correct, that kind.
Okay, we
Yeah.
should all do that.
Yeah,
But he has one, it's black in color, then he just pull to the class.
You just racially like.
Yeah, back in the days.
No, he really like pull. Okay, but never mind, it has evolved. Okay, anyway, this one. Shh. BC parallel to DE, ratio of the area of ABC, the small one, to the big one. It's 9:49. Now they go reverse. So that means area of ABC, I compare it with area of ADE. They tell me it is 9:49. Yes, but I know, not square, square root. But I know that the ratio of their base, for instance, they write AB and AD. So actually, AB and AD, AB with AD, this is just one of the side I picked. Okay, AB compare with AD, square will give me 9 out of 49. So in order to find the ratio of one pair of the side, I square root. So it is 3, 7. So that means this part here is 3 units, not 3 cm, it's 3 units. This part here is 7 units. So if I want the ratio between AB and BD, what should it be? 3:4. Okay, so you just need to take out the proportion and compare them. Okay, last one. They say area of ABC is 54 cm square. What is the area of this trapezium?
Trapezium formula.
No need.
45 by 9.
Okay, good. So actually what I'm told is that this ABC is actually 9 units. The area of ABC is 9 units. So 9 units is 54 cm square. So 1 unit is 6 cm square. Yes. So once you know the ratio already, the rest is like your primary school units. What 6 times 4? You can find the whole thing, then minus the 49. Or you can go and find the remaining 40 units.
40 times 6.
Yes. So because this whole thing is 49 units, you subtract off the small triangle. So this part here is 40 units. So you go and find 40 units is 6 times 40. So 240 cm square. So the second part is quite self-explanatory. Because the whole triangle, the big one is 49 units. This small part here is 9 units only. So it tells me that the remaining trapezium is 40 units. So you just go and find the proportion accordingly. You hearing things? You okay no? I feel today like a bit like off or every day like that.
Yeah, you just don't see.
Okay, can. Okay, sure. You lock where? Lock down. Okay, example 3. I have a trapezium where AB is parallel to DC. So done already. Whose? Oh yeah, he's all over the place. Every time like that one. Okay, the diagonal AC and BD intersect at E, and AE is 10, EC is 6, the area of CDE. Okay, let me shade for you. This one. This piece here is 13.5 cm square. So explain why CDE and ABE are similar. When they say explain, they're asking you to prove. So I want to prove that these two are similar. First thing first, these two angles are the same.
Yes.
So you can write for me. Follow the order. CED. So CED should be equal to AEB.
All the angles are the same because of the parallel line.
Yes, but you only need to prove 2. So first thing you tell me this one same because of vertically opposite angles. Next pair you can pick is the alternate one.
Yeah.
So this one.
Other cells.
So you can write down. So let's say I want to call this angle ECD. So the order is important, right? So ECD. The next order will be EAB. Then you write alternate angles CD parallel to AB. Just show 2 angles will do. Then you tell me by AA test. Triangle CDE is similar to triangle ABE. A what?
It's just some letters.
Yeah, it's just that 5 scenario, 3 scenario, 5 C's and 3 S's.
Like this one.
Yes.
If you don't put the reason, like manipulate.
Then you might get deduction on marks.
Okay.
Yeah, so remember the reason. The last page of the notes.
What's the difference between alternate angles?
You see, we have 2 parallel line. When you see the letter Z is alternate. So this is alternate angles. This one and this. Okay, really, Ravan?
Student Anthea from class 1B and student Iris from class 1C. Please report to the GO. Student Anthea from class 1B and student Iris from class 1C. Please report to the GO.
Okay, 3 cases. When you see the letter Z is alternate, letter F is corresponding, and then letter C. Okay, letter C is interior angle. So these two, the special thing is they add up to 180. They are not equal. So this is interior angles. So 3 cases for parallel lines. You learn in Sec 1.
Actually, in primary.
Yeah, Sec 1 or primary have already, huh? Okay.
Sorry, I forgot.
Okay.
You must remember. You lose marks.
Okay, so now, right, I want to find the area of ABE. This one, the green triangle. So I know these 2 triangles are similar already. If I want their area, let me call this A1 and A2, so it's easy to write. Let me label this A1, A2, then I can use already, right? So ratio of area of A1 is to A2 is L1 over L2 squared. So I need to pick a pair of sides that are corresponding. So it's between 6 and 10. So 6 and 10, you square it. So you have 9 and 25. So what I know now is this small piece here is 13.5. Okay, this small piece here is 13.5. So 9U is 13.5.
Why did you choose 6? Is there like a whole other triangle?
No, 6 is this part, what? Then 10 is this part. I'm picking the one corresponding side. The yellow triangle, I pick one of the side 6. Then the green one, the other side is 10.
Oh.
Yeah.
Miss, you can't just flip it up.
If you want, you can, but you just visualize how it looks like. Okay, so if you want, let me try to flip it with technology for you.
You should also do that.
Okay, so can you see that they are actually corresponding sides, your 6 and your 10. This one compare with the 10. Okay, they are the matching sides. So if you know that this is 13.5, okay, then now you can find the next area. Okay, alternatively, you can bring this entire chunk below. This is a shortcut if you want. That means bring the A2 up and then bring this entire fraction to the bottom. Swap their position. Okay, then you calculate. Ravan,
Yes?
you copying anything or not?
Pay attention.
You
We got
Reach up to the top.
you like talking to Kale. You were listening to him. To him lah, not me. I go there, your notes empty one, right? Or you don't have notes? You copy anything or not? Okay, so knowing this is 37.5. Now question say, can you find BCE? Okay, can you find BCE? So what can we... Wait, we want to find BCE. Then is the other triangle already. Are we able to find BCE?
I agree with that. So we should leave the question.
No. I have A, B, E. I have C, D, E. But the two are not. I can't find BCE what? When there's a will, there's a way. Okay, wait.
Find it. This one. We'll find it.
Okay, the ratio doesn't lead me to be able to find that. Okay, wait. Unless y'all also don't know the angle. Unless we do half times base times height. If I know the height, I still cannot find that what?
So we should
Okay, never mind. This one we leave it first because I want to tell you the... No, I'm not done yet. Okay, this one we come back. I go and look at it. What is the missing info? It's weird.
maybe it's wrong.
Important thing. Okay, but anyway, the next ratio that I need you to know, the proof is here, but they are telling you when volume is 3-dimensional, you want the ratio of volume, you just cube it. Cube the ratio of one of the sides. So area you square, volume you cube. So the important thing here is they will always tell you this keyword geometrically similar. If they tell you two 3D shapes are geometrically similar, you straight away can use this. And the A1, A2. For what? What thing 4/3? You sphere, is it? Sphere formula. Okay, that one is finding actual. I don't need the actual, I only need the ratio of the volume. So I don't need you to memorize what is the formula of the shapes as of now. Okay, so we look at these two shapes. Two can of milk powder, geometrically similar. The height is 10. Okay, and then they say the base of the radius of can A is 6. So can you find the radius of can B? So in order to do that, I know the ratio of their sides are the same. So R is to 6 should be equal to 14 is to 10. So just cross multiply your 6. Okay, you will get 8.4 cm. So that's the first part. This one is the most easiest one, just ratio, right? Okay, second one. They say, can you then tell me what is the ratio of the volume of can A to can B? So what is volume of can A to volume of can B? No need to find actual. What should you do to the ratio? Cube it. So just choose one of the pair. Choose the one they have given. Don't use the one you have found in case you make a mistake. So 10 is to 14, you cube it. Okay, shh. So they want ratio, right? You don't give me in this way. You must rewrite it as 125 is to 343. Okay, if they ask for the numerical value, you give me that. Okay, but if they ask for ratio, you must leave your answer like that. So don't lose marks because you never read the question properly. Okay, next one is weight. When they say weight,
Can I ask a question? But it's not really. It's really.
okay, cannot.
No, but it's how to ask
For?
Let's say it's a fraction, right? But then it's hard to write down the final answer because it's
Okay, usually the fraction will be integer value, numerator and denominator. If it's decimal, you go and simplify first. Then you can express it like that. Yeah, rarely we will have decimal in a fraction. Okay, this one, when they use weight, we are also talking about the amount of space it occupies. So it also follows V1, V2, but we can say W1, W2, L1, L2, Q. So whether it's weight, whether it's volume, whether it's capacity, it is all three-dimensional, the amount of space it occupies. So it follows the same ratio. Okay? Yes.
The similarity of frequency type is covered at O levels. But what is the frequency and difficulty?
What is the frequency? Confirm tested. It will definitely appear in paper 1 or paper 2. Difficulty can be easy. Can be easy. If not, it is the proving there is a quadrilateral kind of difficulty. It will be like they mix the stacked triangle or the ribbon. Yeah. Okay, anyway, now they tell me that can A is 205. They want you to find the weight of can B. I already know that the ratio is this one, same. You have already found. They just change the word from volume to weight. Okay, but it's the same ratio. So just go and cross multiply and find the answer. So weight of can B is 205 divided by the entire fraction. Okay, or you can cross multiply, but I'm just taking a shortcut. So answer is 562.52 grams. Or nearest gram. So you give me 563. But they say they want you to correct to the nearest gram. So normally we leave it. But because they ask you to correct, then you must change. You cannot. Yeah. Got one part left. Okay, cost of the can 840 and 1950. Which one better value? This one set one question. So you can just for can A, use your 205 divide by 840. Can B, use your 562.52 divide by 1950. Then you go and tell me what is the gram per dollar. Gram per dollar. Yes, then you just tell me which one is better value. This one is about 24.4 gram for every dollar. You can get 24.4 gram. This one is, milk powder is super expensive these days. It's crazy. Okay, which one better value? This one, right? I can get a greater mass of milk powder per dollar. So this one, I get more milk powder per dollar spent. So this one can be has better value. This one better value. Yeah, this person every day
so
flying about.
I'm so studious.
Okay, perfect timing. So proud of myself. Okay, so today you can go and do this example 5 only. One example. But this PMP optional. Okay, if you want, you can go and test your understanding. Okay, oh no. Maybe I shouldn't make it optional. Wait. Just do 9, 10, 11, 12.
How would you do that?
No, I seeing you all tomorrow. Today got CCA. Okay. Just one example, this one.
So one part.
One example, the whole example. Okay, wait. Listen, tomorrow, please bring your construction set. If you don't have the whole set, just bring the compass, the one with the needle and the pencil, and then your protractor. Sorry? We are doing construction tomorrow by sector.
I have a verse one also, but I want to tell you.
You want to what?
So basically, right, my parents moved, and I didn't take the set with me. We're only going back on like weekends.
Okay, I have one set in my locker at level 3. You can take it tomorrow morning. But if it disappear because other people take that, I cannot. Okay, so you can use that set. Okay? Bring construction set tomorrow. You should start learning how to use it. Of course. Yeah? Weight, volume, capacity, same. Sometimes they use mass, also works the same way. It's just without gravitational pull. Yeah, I take physics last time. Although, you sorted it out. Okay, class 10. It's Thrive now. I can close, right? This one. Okay, just one example that we were left with. Okay, so one look at it, you know it must relate to volume lah, in one way or the other. So first thing they say, I have a cone. The height of the cone is 8 centimeters. The radii of the bases of the small to the big cone is 3:6. Find the length of MN. So there is a similar triangle that I want to point your attention to within the cone. So if you want, you can extract that set of parallel triangles out. So V, ND, MB, then they tell you this whole thing is 8. Your goal is to find this. You have this being 3 and this being 6. And these two being perpendicular actually tells you that they are parallel. Okay, because these two are corresponding angles. When corresponding angles are equal, you have parallel lines. So in order to find MN, I'm going to use my ratio to help me. So 3:6 should be equals to VN is to 8. Okay, VN is to 8. So you cross multiply your 8. Vn is 3/6 of 8, which is 4. But we are not done, right? Because question asks for Nm. So all you have to do is just take the difference. So your Mn is 8 minus 4, which is 4 cm. Okay, so finding ratio, no problem. It's just creating your similar triangle and find the ratio. Shu, why are you following, right? You're so far away. I don't even know if you are there. Like there inside you. Is that? Why? Okay, B. Now we start to talk about area. Ratio of area of the upper base to the lower base. So this is the A1 that they are talking about. The lower base, the upper base. And this is the lower base. Okay, so the upper base is the black semicircle. The lower base is the red semicircle. So in order to find the ratio of their area, so area of upper base. Okay, if you don't want to write this, then on the diagram you put A1 here. Then here you put A2, then you can use it directly. If you don't want, then you have to write this. Okay, area of lower base, it's L1 over L2 squared. So you can pick one pair of ratio that is from the diagram. So what is the relevant one is of course the 3 and the 6. Okay, which is the radius of the semicircle. So I'm going to pick the 3 and the 6 and then I'm going to square it. So that gives me a ratio of 1:4. Okay, so they want the ratio, you give it to them. This is 1:4. Don't give me 1/4 because they ask for ratio, not the value. Okay, so this is part B. Okay, last one talks about volume. They say the volume of the frustum, okay, if the volume of the cone VCD, the small one, is 42 pi. So I'm going to just redraw it a little bit. So this one is the big one and then the small one here. So they tell me that this part here, the missing part there, is actually 42 pi. Okay, for volume. So they want you to find the frustum, this one. What is the volume of this piece? Okay, so what I know is the volume of the small cone and the volume of the big one. Yes. No, they want the small part. The blue portion only with the missing top cone. Yes, yes. This part is a frustum. Okay, where you chop a smaller cone from a big cone, the bottom part is called frustum. Okay, so volume of the small cone to the entire cone follows the ratio of one of the sides. So 3:6 again. But remember, because it's volume, we cube it. So the ratio is the cube of the ratio of one of the sides. So you get 1:8. So this small cone, it's 1 unit. Yes. Can. So the small cone is 1 unit and it's shown here. So they already tell you 1U is 42 pi. So if you want to find the bottom part, actually essentially the bottom part is how many U? How many unit is the bottom part? 7, right? Because the whole thing is 8. Then you minus the 1U on top. So the bottom part is 7U. So you can just go ahead and find 7U. So times this whole thing by 7. They say express your answer in terms of pi, right? So don't press this value of pi. Just leave it. Don't even key into your calculator. Just leave it here and just multiply 42 with 7. Okay, when they say leave your answer in terms of pi, don't evaluate the pi. Leave it there. Okay, leave answer in terms of pi. So 42 times 7 is 294. Okay, cm cube. Okay, so frustum is the bottom part where you chop off that small tiny cone. Just the blue portion here, this one. Okay, usually we will 3SF, but because questions say leave your answer in terms of pi, so you leave your answer as this whole thing. So I hope you can see, if they talk about area, you square the ratio. If they talk about volume, you cube the ratio. And then if it's just ratio of the length, you just use the ratio directly. So this is the one-dimensional calculation, two-dimensional, three-dimensional. One, two, three. Yes, 5 marks. 1, 2, 2. Okay, we try a few more questions from PMP. Just the volume part. 10, okay. Why leh? 10 looks scary, What about 7? 7 can do or not? Why do I have notes? Why are you floating again? Done? Can. A lot of empty seat, you can just move forward. Okay, two-dimensional and three-dimensional shapes and figures. So when it was length, okay, when it's 1D, one-dimensional length, right? Distance, radius, any kind of length you can think about, height. Okay, there is one-dimensional. Okay, the radius, height, base. Okay, any kind of ratio. We know that L1 equals to L2 is L3 equals to L4, etc. So the ratio of the corresponding sides will always share the same proportion. Okay, but when we go 2D, that means we go into area. Then when you want to find ratio of two different shapes that are geometrically similar, then you basically square the ratio. Okay, because it's two-dimensional, now you multiply the length by itself. Okay, then when we go into three-dimensional shape, which is volume, okay, example of things like weight, yesterday we were saying, capacity, okay, volume, they will use words like this, but whichever word they use, if it's a 3D space, they occupy a certain space, okay, you know it's V1 over V2, L1 over L2 cube. So that's the only three things that we have learned. Okay, this one could be surface area, okay, could be just area, but it is, yeah, it is 2D. This one is 3D. Okay, so I told you all about how similar triangles will always be either a pair of stacked triangles with a pair of parallel lines or in the form of a ribbon. Okay, with a pair of parallel lines. So this is everything. In fact, 6.1, 6.2, 6.1, we have your 5 congruency tests, ASA, AAS, SAS, Triple S, and RHS. So that was 6.1. Then 6.2, we have your similarity test, which is your 3S. So SSS, SAS, and AA tests. So that is the bulk of the chapter. And then 6.5, we will learn how to construct angle bisector, perpendicular bisector, and triangles or quadrilaterals. Okay, so that one we will practice in a bit, but let's jump by the last. Okay, this one, let's just jump into 7 very quickly. They tell you ratio of surface area. As long as it is area and it is geometrically similar, they are telling you that A1 over A2 is 49 over 81. You realize that the numbers are perfect squares. So it is the same as L1 over L2 squared. So if I want to find the ratio of one of the sides, I basically need to square root it. So actually what I know is that the ratio of one pair of the sides is always 7:9. Okay, so it's a good information to square root it so that you know what is L1 over L2. But they want ratio of volume. So what do you think you need to do? You just basically cube the ratio you just found. So that's why you will get the answer 343 is to 729. Then you just go and find the answer as per what is given. This is the small cone. So 343U is 857.5. Go and find 729U. Okay? So this one, not difficult, but I just need you to know that you need to relate back to the ratio of the length. Okay? Today is it even lesser than yesterday? 4, 6, 8, 10, 12, 14, 16, 18, 20, 23. 5 go France, 2 more is who? Qi Hui and 1 more? 5 went France, right? So minus Qi Hui, 1 more? Oh, Christabel.
Bonjour.
What?
If you go to the library.
No, she will.
Can we have a map?
She will catch up. Don't worry.
Teacher says
He's starving. Then borrow his pen and eat. Oh, apple. Borrow, then return another day. An apple for an apple. What? No. Okay, move on. Okay, 10 as requested by Ravan. Jug X, jug Y, jug Z, they are all geometrically similar. So we are looking out for this word. That means we can use all the ratio we want. The L1, L2, A1, A2 squared. Or the V1, V2, L1, L2 cube. So if they tell you this, they are telling you you can use this freely. Okay, next, they say the volume of the jug X and Y. So this one is 216. This one is 512. So write in first. Then find the ratio of the surface area of jug X to Y. So first thing first, I know Vx over Vy is 216 is to 512. So this is also the equivalent of Lx, Ly cube. So in order to find the ratio of one pair of sides, I cube root it. So when you go and cube root this, what do you get? I get 3 over 4. Okay, look at the answer for blindly, right? Okay, but I want ratio of their surface area. That's where you need to square the ratio. So area of X is to area of Y. You square this ratio, and that's how you get 9 is to 16. Okay, so that is part A. Okay, next it says that the volume of jug X is given by this formula. 7 over 15 R square H. So they say I can find volume of X by using this formula, where H is the height of the jug This one is H. And then the radius of the circular base is just R. So that's what the question is telling me. They say, can you now find the volume of jug Z, okay, which has the height that is 2/3. Yes.
What's that formula?
They just gave you a formula to represent the volume of jug X. So you just follow first, then we see what they want. So now they tell me that the jug Z, right, the volume is 2/3 the height of jug X, and it is twice the radius of jug X. So that means instead of R, this is 2R. Okay? So using that same formula, jug Z is 7 out of 15. Okay, the radius that I square is a 2R squared. The height that I use is a 2/3 H. Okay, so using that, whatever that I have there, I have a 4R square, a 2/3 H. So if I just don't touch this 7/15, this R square, this H, because I want to maintain this there, so I will keep my 7/15 R square H on one side. Okay, because I want to compare it with Vx later. Then whatever that is left over, which is my 4 and my 2/3, if I calculate, it gives me 8/3. So this tells me that my volume of Z is 8 out of 3 of my Vx. I just plug that only. So I already know my volume of Vx, 216. Just now they tell me already. So to calculate it, I just 8/3 of 216. So it's just comprehension of what the question wants. No, but you see, the solving is very logical. You just follow their instruction first, then see what they want.
So this is easier than PSLE.
Do it yourself.
How many marks?
Okay, you see the first one, you need to cube root, then you square root, final answer. So this one is 3 marks. Yeah lah, but there will be questions like that, but not all questions are like that. There will be 1 or 2 that looks like this. Yeah, but nowadays they just like to mix the language with the, yeah. But can your teacher who is not very good with English can ace the math, you all can do it also. Are you a lead class? Oh, you're not a lead class, but you all can. Your English better than mine, right? What? I don't take lead. I cannot. I don't know where is the between the line. Can never find that. Okay? So this is 10B. Collect, yeah, because I wanted to double check the marks that I recorded. It was a bit, but what? Yes?
Do we have our chai?
Oh, it's the tea, huh? Okay. We wait for everybody to come back. This is like,
By the time I eat the tea, I had a headache.
you ate the tea? You realize the either got grammar or mistake,
But I
right?
did eat it.
Yeah, that's why the headache happened. Okay, so I think you roughly get the sense of how to use the ratio for volume, for area, for length. 3-dimensional, 2-dimensional, 1-dimensional. So it's only, they can tweak around with this kind of, they can change the shape to any fancy shape. But as long as they say it's geometrically similar, the ratio of any pair of the sides will be the same throughout. Okay, so they give you jug, also don't need to be scared. You don't know how to find the volume of jug, they will tell you. They say use this formula, right? So don't have to worry. It is rarely the case where they need you to actually use formula to calculate area or volume. They will give you the ratio. Okay, so let's move on to the drawing. Last part. No need lah. Okay, I want to tell you that actually I don't need all those tiny parts. This one, This tiny part I don't need. The only thing I need is this one. To explain to you what is perpendicular bisector. So you roughly can understand from the word perpendicular and bisector that this line, if I have a line segment AB, okay, line segment means a line, I chop it at two ends, so the end point AB. If I want to draw the perpendicular bisector, this line must be 90 degrees to the line that I have, and it cuts it into half. Yes, because today we need to draw. Okay, so this line that you need to construct, there is a way to use your compass, your protractor to draw. Yes, you need to draw an arc. So before that, but I'll tell you some properties about this line, is that at any point that you draw on this perpendicular bisector, it will always be equal distance or equidistance away from the two endpoints. So you pick a very far point on this line, it will still be equidistant from B. So any point that lies on this line will be equal distance away from either of the endpoint. So your mission is to construct this line. Mission. Okay, in A Math, you learn how to find equation of this line already. But now you need to know how to draw it. Okay, so all this technical part, I don't need you to do that part. So we are going to skip. Yes. Can. Okay, so you cross out all the sections. All this not important. This one is what I want. Okay, this one is what I want. So if I have an angle, you know angle must be formed from two line segments meeting at a point. So this is my angle. Okay, must be one corner point, right, that you have. If I want to draw a line that bisects the angle, it's called an angle bisector. So there is going to be this line that I will draw that will cut this angle into half. So if this angle is a 60 degree, this line will cut it into 30 and 30. It will directly bisect the angle. So this is the line that we will learn how to draw, how to bisect the angle into half. But the thing about this line is also the same thing. If I drop a perpendicular line to the two line segment, it will also be equal distance away. Okay, any other point I pick, I drop a perpendicular line to the two arms I have, it will always be equal distance. So these are some things that you need to know, but the main goal is to draw that line. Okay? So all this not important, no need to run through that. We don't need the details of that part. Then we will jump to the drawing. Okay, do you need to draw this tiny thing? No need, it's at the last page, already drawn for you. Is this first one, angle bisector. Okay, so if you have an angle here, you know you need to draw a line that cuts this angle into half. But what is the scale involving that? Okay, I'm going to do to that what I want so that you can see. Okay, so what I drew just now is here. The steps of the construction is also written there. Okay, but I'm going to show you two videos now so that you can draw. Okay, so the first thing I'm going to show you, so just now what I draw, you don't need to redraw. It's actually on this page 8. It's already drawn there for you. Okay,